why are oil and gas so important? Why do we have a whole class devoted to them? Well, the short answer is that oil and gas built the modern economy, and they're still most of what the economy runs on. So if you want to understand why the economy works the way it does, why manufacturing jobs go one place and not another place, the balance of geopolitics, what the big issues are in the news, which countries are doing well and which countries are doing poorly, you really have to understand oil and gas. And the basic reason for that is that everything we have in our modern economy is touched by oil and gas. Most of it is manufactured with oil and gas. So if you were to order some consumer product on Amazon, you'd be doing that on a computer largely constructed of materials, plastics and rubbers, etc., made from oil and gas. You would be doing it using electricity that in all likelihood would be from burning natural gas, which is our largest source of energy in the United States. You would be purchasing it from a factory where it would be made using these sources of energy and likely constructed using oil and gas. It'd be put in a shipment. That would have tape on it, also made from oil and gas, and it would be shipped to you on a plane and ultimately probably by a truck, all running on oil and gas, tires made of rubber made from oil and gas. And so oil and gas touches every aspect of the modern economy. And it's for that reason that it has so much to do with how our economy does. So since World War II, all but one of the recessions we have had has been caused, at least in part, by a rise in oil and gas prices. And when oil and gas prices rise, all the things that we want to purchase, since the vast majority of them are made with oil and gas, become more expensive. And it becomes more expensive to get them to us because they are must be transported, and that all takes oil and gas. And in fact, people don't want to drive places, they don't want to fly places, and that causes a recession around the world. So it's really crucial both to our global economy and to global geopolitics. So to understand how we use oil and gas for all these things, it's helpful to really understand what oil and gas are. So let's start with what oil and gas are. You may have heard that oil and gas are hydrocarbons, and they are. They're hydrocarbons. That means that they're made of carbon and hydrogen atoms. So if you can remember back to high school chemistry, you may remember that carbons can form 4 bonds. And so the simplest hydrocarbon molecule, the simplest molecule in oil and gas, is a methane molecule. And that's what natural gas is mostly made up of. Just one carbon, so it's a very light molecule, which is why it's a gas, not a liquid. And so that natural gas is this one right here, one carbon with 4 hydrogens surrounding it. Now you can link those carbons together and have a longer chain of carbons. You may remember that from chemistry as well. So you can have 2 carbons and that forms ethane. You can have 3 carbons and that's propane. And you can have 4 carbons and that's butane. And as you link carbons together, those molecules become heavier and heavier. And so when you go to methane, ethane, propane, butane, even to 4 carbons, it's still mostly going to stay a gas, but if you were to compress it or cool it down, it might turn into a liquid. And by the time you get to pentane and hexane, 5 carbons and 6 carbons, you're talking about liquid that you're talking about molecules that are normally liquid, and they form the basis for gasoline and all these other products that are made from oil. So that mix of all these different molecules that form liquids, pentanes, hexanes, octanes, that's called crude oil. That's all those molecules mixed together. Now the way these molecules are created is that there are decaying organic matter that for millions of years sat under the earth and was pressed together under intense heat and pressure. And it is transformed into a mix of these oil and gas molecules. So some are those really light ones that are gas, like methane and ethane, and some are kind of in the intermediate where they can be sometimes gas and sometimes liquids. We call those natural gas liquids, like propane and butane, and then some are always liquid. Those are our crude oil sources. So oil and gas really exists on a spectrum, and you can go up to much higher numbers of carbons. And at that point, this would be a little bit of a sludgy. That would be, still be crude oil, but it would be sludgier. It wouldn't move as well, and it would be heavier. So we can also talk about light oils to heavy oils, and we'll talk more about that in a second. So what's so great about oil and gas? Well, one thing that we've discovered over time is that we can make almost anything using oil and gas. We've learned how to make plastics and rubbers, and that's pretty much where all our plastic and rubber now comes from. And we've used that for most parts of our industrial economy. So they're really useful for making things. But of course, the main thing that they've always been used for is burning for energy. And where they're really beneficial there is that they are incredibly energy dense, which means that you can have just a little bit of it, carry it with you, and use it for all the energy you need, which allows you to fly planes, allows you to drive trucks, allows you to have ships going overseas. And that's the huge advantage of particularly gasoline and those mid-range carbons, 6 carbons, 7 carbons, 8 carbons, is they store a ton of energy, not too heavy, and not much space. There's lots of other sources of energy. We have exciting sources like solar power, and we have some sources that have been around for years, but we're getting better and better at them, like wind power. We've always had windmills, or hydropower. We've always had dams. Those are very have a lot of power, but they just don't have it in a usable form to carry with you. So, for instance, maybe comparison is if you have one of those giant offshore wind turbines, right? That would, produces a lot of energy, but it's nothing like the amount of energy that's stored if you had an industrial facility of that size for oil. So, one offshore oil rig would brings about as much energy per day as thousands of those windmills. So you have a lot of energy concentrated in a small space, which means you can bring it on the airplane and fly with you. You can't bring the turbine with you, obviously. This is a chart that shows this, and what you can see is that there's two ways to measure energy density. One is by how much energy you can store in a small space per liter, and one is by how much energy you can store in a certain amount of weight per kilogram. And what you can see is by both of these measures, diesel and petrol, i.e. gasoline, those are the most, by far, dense forms of storing energy to take with you when you need it. You can use coal, but it's not as good. And wood is even worse. Things like the kind of lithium ions batteries, or the batteries that you would find in a Tesla, they're getting better, but they're way, way, way behind. You have to carry a lot of weight of those to carry a similar amount of energy. So that's the big advantage of oil and gas, and the reason that they're able to power the transportation we need for the modern economy, because you can bring your energy with you. Now, this is a complicated chart here, but I want you to look at it, and there's a link here if you want to look at it a little bit more carefully. But what this is doing is breaking down the different types of oil. So we're not going to look at gas anymore. Let's just look at that mix of hydrocarbons that comes in that oil that we find underneath the earth. And we'll see that there's a lot of different things that you can get out of that oil by breaking it into its component molecules. Because basically you want to take that crude oil to a refinery where you can get it turned into the different molecules that it's composed of, because you can use each of those different molecules for a different purpose. And the way you do it, if any of you have distilled liquor at home, you would know how this works. You need a distillation column. So you'll look at this distillation column. What this does is you heat up that mix of oil, and the lightest molecules will evaporate and turn into a gas and go to the top, and they will, some of the medium molecules will go about medium high, and the heaviest molecules don't get very high at all and may never turn to gas. Now, what happens then is that they are siphoned off at different heights, and those heights will correspond with different size molecules. And so you can separate it into the separate molecules that you can use for different purposes. So, as an example here, they have liquefied petroleum gas near the top. So that's going to be a very light molecule. That's probably a propane molecule. So even though you have this, remember, that would probably be a gas, but if it's mixed in with all those mix of different hydrocarbon chains in the crude oil, it could still be in there, and so you're able to separate that off, and that can go off and be used as liquefied petroleum gas for your grill, or for sometimes rural homeowners use propane for energy. You also have ethylene, which is a 2-carbon molecule that's used to produce almost all of our plastics. So that's incredibly valuable. That's an incredibly valuable kind of molecule also that we get from crude oil. Then you're going to use some of that crude oil is going to be turned into gasoline. And because we said that's the highest energy density fuel that you can have practically, unless you're going to use something, a nuclear reactor, those gasoline tends to be one of your best value products that you get out of that crude oil. A little bit of a heavier versions can turn into jet fuel. So that's what your airplanes use. And you get a little bit heavier still is what you use for diesel for a lot of that long distance trucking, etc. Then the heavier parts of that crude oil, so the really long carbon chain, sludgy molecules, they can still be used for things. And they're used for a variety of stuff. So some of it is used for fuel oil that can run power plants that just run on that kind of sludgy oil, or it can be used for tankers that move overseas on that sludgy oil. Some of it can be used for lubrication oil or waxes that are important to machinery. And then some of it, can just be poured on the road as asphalt. So you can see that the modern oil industry is designed to use every different kind of molecule that's in that crude oil. But the value of that crude oil depends on how much of each molecule you have to some extent. Because, as you might imagine, I said one of probably the single most high value thing that you can get out of crude oil is gasoline. And so it's ideal if you have a crude oil that has a lot of those molecules that are good for making gasoline in it. As it turns out, and as you may have seen from our chart, that typically means lighter oil molecules. So they're not natural gas, they're not gases, but they're like some of those really light liquid molecules, those octanes, those hexanes. Those are ones that are particularly valuable. And so that means because every kind of oil that you get from every different rock formation around the world has different mix of different chemicals in it, different hydrocarbons. It's great if you can get one that's lighter, and so you can make more gasoline from it. And so what you can see here on the bottom is a comparison of two different kinds of crude. So on the bottom left, you will see that one kind is one that we have a lot of here in Texas, which is this West Texas Intermediate light crude. And what you can see there is, because it's a light crude, if you break down what all the oil in that crude oil ends up being used for, you get about 50%, slightly over 50% of it is used for gasoline. Some of it is used for jet fuel, and some of it is a little bit heavier, used for fuel oil. But the majority of it is used for gasoline, and that makes West Texas Intermediate very valuable. By contrast, if you look right below that, you can see Maya heavy crude. That's a heavy crude. That means it's sludgier. And that means, yes, there are some smaller molecules that you can turn into gasoline. So about a quarter of it can be turned into gasoline. But the majority of it goes to these heavier uses. It's fuel oils, it's lubrication and waxes. It still has value. It's just not as valuable as those light oils. So what I want you to also see in looking at this chart is on the top left, there's a breakdown of different oil types. And the first way that you see top versus bottom is organized is that the top is light oils and the bottom is heavy oils. And so that's probably the first thing when you ask, what kind of oil do you have? You wonder, is it light or is it heavy? Because the light oil will produce more gasoline, usually be more valuable. The other way these are organized is sweet versus sour. So you can see that West Texas Intermediate that I was talking about, that is a light sweet oil. So what do you think sweet versus sour oil means? Well, it's actually pretty much like it sounds, which is to say, when in the old days, when you got oil coming out of the ground and you wanted to see what kind you had, you put your finger in it and you tasted it. And when you tasted it, it would either taste sweet, basically normal, or it would taste sour. And what sour meant is that there were different pollutants in it. The most common one would be sulfur. And sulfur has a sour smell and a sour taste. And so what a sour oil and gas, that basically means that it has some impurities in it, and you're going to have to take those impurities out before you can turn it into gasoline or the diesel or the other things that you want to sell. And so that typically makes it less valuable. Usually the things that you take out of it, the sulfur, you can sell to somebody else, but that's an expensive process. Usually you'd rather just have that sweet oil that you don't have to do anything to. You just have to break it into its component parts and sell it. So those are the two basic ways that we talk about oil and gas. Is it heavy or is it light? And is it sour or is it sweet?